Hello, welcome. I'm Bill Wake. We're here this week. We're going to start a new project. It's going to be an Elm interpreter written in Swift, and you're here for the very first episode. So here we go. Happy New Year to you all, and please feel free to introduce yourself in chat. Be nice to each other, of course, but if you have suggestions for me along the way, I try and look. I'm not very good at it, but I will look at them while we're coding, and I'm happy to take suggestions. Um, I'm not, wow, should I start off with the things I'm not expert in? Because there's a lot. It's a long list. But unfortunately, it includes Elm. I went through Richard Feldman's book, which I think is great, but I don't have the depth that I kind of wish I had in in understanding Elm. So I thought an interpreter would be a fun project to work on for that. And Swift, I haven't done it commercially. I've been doing it over the last 9 months or so as part of my Twitch sessions, and so I've got some use of it. But it's 9 months of 6 to 8 hours a week or something. So it's not like anybody else would call 9 months. Um, but it's in the same vein of language as lots of other languages. We're also going to look at uh, parser combinators, which is an approach to parsing I haven't used before. I've read up a little bit, okay, and I don't know what else is going to come up. Certainly types and that kind of thing, because that's part of Elm. So it's a journey. If you're with me, that's cool. We'll take those steps together. Okay, so I took some time to write out some cards and just get some ideas going about how to start this project. I've got a few resources I'll point out later, but I want to learn more Elm. I want to learn more Swift. I want to learn about parser combinators. That'll get me going. That's more than one episode, I guarantee you. From a syntax point of view, the starting points, comments, either single line or nested, are kind of a minimal thing. Literals, true, false, ints, floats, stuff like that. Character strings and lists. Those are the basic data structures. I mean, there are more, but that'll get us going. This notion of parser combinator, a parser combinator it's kind of a functional approach. Well, I should say it is a functional approach, and you basically have functions that can parse and functions that can combine parsers, and so you're sort of making a high level function that builds the whole parser all as one giant function, and they work top down. So if you're familiar with recursive descent or LL parsing, they're in that family, but they do allow backtracking. So they're a little more general and potentially a little slower because of that. Although, somewhere I had a paper about, we can compile, X 100,000 lines a second or whatever on some computer from, 15, 20 years ago. The computers have a few extra cycles for us, so the backtracking is probably not a big issue if we don't let it get too crazy. Let's see. Abstract syntax tree is sort of a notion of like you've parsed something, but parsing it just says, does it meet the grammar? You need to spin off something to let you basically, we're writing an interpreter, so we want to have something to interpret. It's tricky to interpret the raw characters. Even like very old school basics had a little bit of processing to let them pre-process the lines, and have a little bit of an abstract structure. Normally these things get formed into trees. So if you have expressions a plus b, it's usually a tree with plus and then a and b. And if it's also plus c, that can be put on there too. So you get this tree notion, and then we have the interpreter notion. I don't want to compile it to some other language. I just want to look at it and decide what I should do if I had compiled it and just do that. So I pay an overhead price. Interpreters are almost always slower than compilers, but the benefit is I have more control of what I'm doing. I have more complete context and so on. So it's all right that way, and it's a great starting point. And somewhere down the line, if I'm still energetic about it, I have a refactoring that converts an interpreter to a compiler, and I'd like to play with that and see if that would work with this situation. But let's get an interpreter first. Before we do that, let's get something working, We've got testing. I'm a TDD kind of person, so we'll be doing testing along the way. There is an approval testing package. Luell and Falco developed this. You basically run something, it gets the output, you look at it, decide, is this acceptable? If it is, you kind of lock it down. This is also called golden master sometimes, or pin down tests or characterization tests. But you lock down the current behavior, and next time you run it, you make sure it has the same behavior. Okay, easy. Next thing is railroad track syntax. And when I was prepping this, I don't know, I spent literally hours. It's like, this should be easy. And it turns out not to be easy, but there's a way of writing a grammar called a railroad diagram, a railroad track diagram. And you're sort of saying, like, you go down the railroad tracks and you say, hey, there's this factor. I'll jump over to the factor railroad and run down that track, and it may let me loop or things like that. I originally saw it with Pascal like years and years ago, but I always thought it was a nice little syntax. So I tried to do it in GraphViz or Dot. They're tools that go together. It lets you create graphs, but getting it to do what I wanted it, oh my gosh, it was about probably 3 to 4 hours to get just this most simple little diagram together. I'm sure it would get easier with time, but it just didn't have quite the flexibility. So my theory is I'll do it some other way. But my hope is, one of my hopes is, we'll spin off some stuff that's useful to the Elm community. So I haven't run across an actual just grammar. I've had people point me to, like, oh, here's a compiler and things like that. But I think it'd be helpful to have just the grammar laid out formally. And we'll see other things along the way. And I don't know, etc. covers a lot, because I don't know how big a project this is, but it's not a 1 week or 2 week project. Let's say it that way. Okay. So today, parser combinators, some sort of literal, evaluate it, interpret it, maybe deal with spaces, maybe deal with comments. I kind of look at it as that we have two ways to go about this. One is by layer. So I could say, let's get the parser done. Spaces, comments, literals, records, definitions, functions, whatever, everything done. Then let's go over and do the interpreter and, interpreting literals and making expressions and operators and so on. It's a way to go. And I probably would have been tempted to start that way, but, kind of this TDD mindset or agile mindset, it's like, no, we want to deliver little bits of stuff. So I would be happier having an Elm that actually parse a little, interpret a little, give me a literal. Parse a little, interpret a little, give me spaces and comments, give me definitions, give me operators. And as we go more and more, it becomes a more and more useful tool with more and more of the language defined. And instead of like trying to get all the parsing done and then at the end start interpreting, I'm hoping the little bits of feedback will keep us going. So we're taking that approach. All right, I've got Xcode set up. I've got Elm has a REPL, read eval print loop, that lets you just write code and test it. I tried the GraphViz. I guess I'll use Keynote. I also have Jenkins and Catlight. So when I push code, there's a loop that polls every 5 minutes and builds, and a little Catlight's a little widget on my screen that lights up green, yellow, or red. We may pull in approval tests, and we'll find other tools as we go. Okay, and my sort of intellectual starting point is this. There's an article, Parser Combinators in Swift. A parser combinator is a higher-order function that combines multiple parsers to form one big parser. Cool. Another one was somebody else had already done a version of combinators on the Mac, on iOS or Swift. And a structure somewhat like they're using, I think, will be a decent starting point. And then a really nice little paper. You could have invented parser combinators, and it just, I'm not going to read it all, but it goes through a whole list of things as we go. So we'll pick up from there. All right. Excuse me. The winter season here. Okay. All right. So start with a function that recognizes a character, generalize it, and then write a function that takes the parameter, and then or and and so on. So we're gonna get that going. All right. Let's see if I quit this. Okay. So what I've set up, I just created a bare minimum Swift project. I created a CI script that will just go build it and run it on one of the simulators, only running the regular unit tests. I don't know that we'll even create any UI tests. It's going to be pretty minimal that way. And when you build this out of the box, I'm using Swift UI, which is sort of a React style text based kind of thing. So I define a structure for the app, and then I can define a structure for the view. This is just a text hello world just out of the box. I can resume this. And it's slow the first time. Okay, so nobody's chatting. All right. Let's see. So we will start here and flesh this thing out. I'm gonna let that build, and let's bounce over to Elm. I'll put a separate one. All right, and let me jump. I had some resources down here. This one is a good starting point for us. Okay. Now, if you're here on chat, don't mind talking. Let me know your experience with either Elm or Swift, and if you're very experienced with either one and can guide me at any point, feel free to speak up because I don't know these things. All right, let's get this back on screen. I put it over there, but okay. So this is basically the elmlang.org, and it's one of their kind of first documents you'll run into. It's just a syntax reference. And so it shows us, here's single line comments. I guess that doesn't show up very well either way. Dash dash gets you a single line comment to end a line, and left brace dash all the way to right dash right brace gives you a multi-line comment, and you can nest these. So in the middle there, you can see another dash brace comment. And they give you a little trick. If you sort of nest them this way, you can make a comment and uncomment easily. Then you have literals, true and false, numbers, which are integers, sort of. Already it's complicated. Floating point numbers, characters, character strings, or including multi-line strings. Now, you can see what I'm saying about lack of a grammar. This doesn't tell me how do I actually fill in strings. Is it like C strings with slash whatever, and do I do Unicode, and how's all that work? I don't know. That's why we have Elm REPL. So we'll start here, I think, with a number. I'm just going to start with 0. It's sort of the minimal program we can write in Elm. And 0 should evaluate to 0, no surprise. But the first surprise is when you type 0, it'll tell you 0, the value, and it'll tell you the type, which is number. And already there's some complication in the type system. We have the notion of int or float, and you can be int or float and be a number. So I don't know, and I've looked around some, but I haven't seen a great explanation of what types are allowed to be, other than implicitly in the syntax we'll see. This is sort of I forget what they call it. It's not an artificial, but it's some sort of type that is kind of predefined to be int or float. And so if you look in the reference, the functions say, you'll see functions that take a number, and meaning they can operate on int or float. Let's see. Let me find my command line. Let's get this out of the way. Okay, so let's run the REPL. Okay, our first target, 0. Wow. Everything's going to be slow here. Okay. Well, my video setup claims it's only taking 5%. Okay, there we go. 0 is a number. All right, now if I do 0//3, it does know it's an int, or it converts it to an int, so that // function. If I do 0 plus 1.2, it knows it's a float, because 1.2 is a float combined with 0, which could be float or int, and gets a float. And I think the reason for this complexity in the type is the target language for Elm, at least originally, is JavaScript. And JavaScript kind of has this ambiguous situation of ints and floats. It relies on storing ints in the floats, basically, I think. I'm not sure how required that is, but it's certainly done that way in some cases. And, so there's, when you see an int, you kind of don't know, is it really an int or a float? I don't know what if I haven't tried this, 0.0. Okay, it's 0, but it's a float. Okay. All right. So, I mean, already, like, here we are, 2 screens in on this. Here are the literals, and you can write expressions, and then we have lists with this : operator to append, or prepend, I guess. And we have an empty array here, or empty list here. It's there's a lot of mechanism to get this far, I guess, is my point. Let's see, I've lost. Let me steal this back. I lost one of my monitor pages. All right. Okay, so we're going to start very basic. I think that it's simpler to skip the comments for the moment. There's some ambiguity in the parser combinator with how we're going to deal with that. I don't necessarily understand that very well, but the minimal program is too boring if it's just a space. So let's deal with just a number, and like I said, 0 will be our first program. So I want to. Oh, there, we finally did that. Okay. We got tests. Okay, so here's a test. It's just the stub they give you out of the box, and we won't need most of it. All right, but let's just start. Okay, so I think we're gonna test. Let's start with wow. I don't know. Maybe we'll do the whole thing. Let's start somewhere. Okay, so I'm looking for. I've been thinking a lot lately about when I write TDD tests, like what am I really after? So what you saw with the syntax thing was, I'm tossing things out left and right. That's too hard. That's too hard. That's too hard. I'm looking for something very minimal and easy. In this case, I think the number 0 is maybe not quite minimal, maybe not quite easy, but it's a reasonable minimalistic thing. And maybe 1.2 is even better. I don't know. But I'm going to do something. All right. And at the end, I want to assert equals. I think I want to say the text is 0 : number. If I'm doing the interpreter. So, whoops. Come on. Okay. All right. So sometimes it's easy to start with the assertion. I think I learned that from Jim Newkirk. Let's see. Interpreter dot. I don't know. Is this output? Okay, so I'm kind of designing what this thing is somewhere. I mean, my process is I want to say let interpreter equal interpreter of something, and then call interpreter.output. And then what I'm doing, I'm sort of saying I'm inventing the read eval print loop. Basically, I'm just going to skip the read and skip the loop right now. I'm just going to do eval and print. Okay, so if read and eval. I guess read, eval, and print. The read is the parse. And so I'm going to do something, which I guess I'm going to say let parser equal, and I'm just going to call it parser. We'll get better names as we go. But if I parse the string 0, I want to get something back. And actually, I should probably say parser.parse of 0. Okay. And I'm getting something. I'm going to say AST, abstract syntax tree. I'm going to say it so many times you won't have trouble remembering it. And you, like I said, you can feel free to complain anytime. All right, so the parser is a parse, and he gets an AST, and then we're going to interpret it. Okay, so the read, the eval, and the print is implicit. You could say the read was getting the string in, and eval is these two together. That's reasonable enough to say. In Lisp, where it comes from, there's not much difference. The syntax is all those parentheses, gives you a nested tree or possibly other kinds of structures out of the box from reading it. And for us, it's going to be more work. All right. So this is what we might call framing a test. And we've got the test. Now we want to do the framing. I've implied the existence of a parser, a parse, an interpreter, an AST, and an output in there. Like, yikes. This may be a big step. So let's see how we do. All right. So I'm going to add a parser. I'm going to do it in here for now. And I'm going to take that example and make a parser. And their suggestion was parser of A for abstract syntax tree. I don't think there's any reason not to spell these out, although most people don't seem to do that. Okay. And it's going to have a function parse that takes, we'll say string, goes to an AST and a string for now and question mark. Okay. So a little bit weird. I don't even know right now, like, what do I want to do for this? Let's make a parser. Well, okay, let's do this. Let's even just do an int at this time. Single argument function types require parentheses. Yes, they do. Okay, so I got parser. I've got an int, AST for now, and missing argument for parse in call. Parse. Let's see if I can find these invented. I'm making a function call out of this thing, so I have to do something a little funny. Okay, yeah, because it's a struct, I have to initialize it here. And then once I have the function called, oh my gosh, already this is becoming a painful, a painful thing. Okay, but my function, I'm just going to get minimal here. I'm going to say string in, and I'm going to return -1. All right, so I'm just, okay, call value of non-function type. Parser subint. Well, can it infer it? Oh, yeah. So, okay. So whatever this thing is, it's going to return my, let's see. Is that going to be okay? Type is ambiguous. Okay, trying to. Oh dear. Definition. Oh, okay. Can I put that in here? I haven't done it this way before. Definition conflicts. Oh, man. Already I'm getting balled up. Okay, I can see my test is way too big to start with. Wow. Okay, let's make a smaller test. Test parse matches digit. Okay, so I'm referring to paper copies of those papers, and my printing wasn't very good on one, but okay. Let's see. You could have invented. So the you could have invented is very nice. Let's go there. Keynote. Okay, so the key idea, he sets it up as you're writing this little interpreter or parser or something, and your boss comes to you with these theories, and you keep implementing them with functions instead of just writing the straight line code. So basically, you start with a function, which is this one inside here, that you give it some input, and it returns you the character that basically the first character of it. And the way you build it then is you write a function that returns the parsing function, parse one character function. Okay, so when you run lit, what you get back is a function that's a parser. Okay, and so trying for that same effect. And then once you have that, you can do or and whatever else. But yeah, I guess this is where you can tell my lack of Swift experience here, that I'm struggling to get this thing formatted out. Okay, so the other paper I'm looking at is somebody that just said Ledger Mac app building parser combinators. And they use that structure, and they're using streams, which we're going to get to in a minute, but instead of strings. But the parse I'm defining is basically the same as what they are. Okay. And I guess let's bring up that paper too. Where's my keynote? Is that this one? Nope, this one. Okay. So we've got parsers is something that takes a string and returns, in this case, an int and a string. This string on the right represents, after you've processed this int, what's left of the string. Okay, in our case, it'll be an empty string. And then the optional is you could fail, because if I gave you the input A or space and said, look, what's the number, you would say there is no number, and so you would fail. So that's fine. This character view thing, yeah, I kind of knew this in Swift. When you start taking characters out of a string, it's actually a pretty complicated process because of the multi-byte stuff or whatever. So you can ask the string to give you an array of characters, and then you just work on these characters. And I actually think I want to use that and an index just to kind of keep things moving. But at any rate, they define this. So the type alias basically switches them to working on character streams, and given a stream, an input stream, produce an AST and an output stream. Okay. And their examples don't actually show calling these things very much, so I'm a little puzzled there. Many will call it, yeah. Yeah, well, we return a parser, so that's always the thing we're doing. And I don't know, where's the call? Let me go back to the other one. I mean, we call parser, or we call some parser function. This would return a parser, and then we call parser on the input. Let's try something more like that. I don't think that's quite what I was doing. Okay. So we're going to let parser equal, and I guess parser's the abstract thing. I want to match a digit. I'm just going to say digit. No. Yeah, digit as a parser. It's a name. Okay, so like, where'd it go? How can I lose Windows so fast? Okay. Like this one, let's a function here. Yeah, let's write a function that returns a parser. Okay, so let's just call a function, and it returns a parser, and then we're going to call parser equal value equals parser.parse 0. Okay, and digit, I'm gonna write that, I think. Well, I think what I could do, let's say I said parser parse colon, and now in here I can put a value of type empty to closure result AST string. Well, I need to return an AST, which I will do. An AST, I'm going to say it should return, we'll just return -1, and question mark. Okay, I'm promising contextual type for closure list argument expects 1. Oh, yes, this is string in. Okay. I'm expecting a string to come in. When I get it, I produce an AST and a string. In our case, we're going to use a AST is just going to be a simple integer type by inference. And the string, I'm just making up a string. So this is my garbage implementation here. Okay. And then when I do this thing, I use it, and then I'm going to make an assertion about it. Okay. And I'm expecting an integer, and parser dot just value. And value has a 0 field and a 1 field. So 0 is the AST, 1 is the string. And I really want 0 because I just want to get the AST value. Must be unwrapped. Can I do that up here? Okay. I'm asserting with exclamation point, I'm asserting that it really does have one of these things, that it will be successful. Okay. And does this value equal 0? This value being my intermediate type that I'm pushing through here. All right. Oh, here we are, 35 minutes in, and we'll get a test that's properly read. Okay, I'm back. Let's see. So it seems like it was trying to run this on my phone. I thought I know I've used it for developer mode, so something was a little messed up in there. Maybe I updated something, or who knows. But anyway, I'm targeting a simulator now, so I did check that it builds. Let's run it. All right, but we expect this test to fail. I guess with a -1, since I just hard-coded a return. All right. So I guess summary, what we did so far, we started with a test. It got balled up and ugly, and I gave up on it. And we spin off what we call a child test. That's a Kent Beck term from his TDD book. It's a smaller test that we can try and get a handle on. Okay, so now let's see what this thing's doing, because it's already kind of weird. I don't know. I've done more OO programming than functional programming for sure, but we're crossing that line here with the combinator approach. So we have a parser. We give it a closure. So this string in thing is only evaluated, when we call parse down here. We're just initializing this object, which is a structure with 1 field, which is a parse function. So we're plugging in this closure into being a parse function. All right. And I'm using the format of it. It takes 1 argument, a string, and it returns a tuple, or a duple in particular, AST and a string. In our case, we're using an int. It will infer -1 is an int, so it must be an int AST. And string, I don't know what happens to the rest of the string. We haven't dealt with that. All right, so this is, it's easy to return 0. Okay. I mean, we can make the test pass, and that's probably the babyest step we're going to get out of this one. Okay. And now it's like, I want this function is actually a meaningful thing. And I think Swift will let me put top level functions, right? Not bound to a class. Let's refactor. So I'm going to pull this. Can I even extract it? Yeah, their refactoring tool is pretty wimpy. But let's suppose I had a function and it's going to take a string. Let's call it. What am I going to call it? Well, I'll call it digit for now. Kind of started there. It takes. Well, it basically does this. String goes to AST string. So it takes a string of type string and it produces a pair and it's got a body. Okay. And in our case, we're going to return this. In Swift, you don't have to put a return, the keyword return, when there's only one value here. Type of expression is ambiguous without more context. I wish you'd give me more context. Let me try it this way. What if I just do this? That should be allowed, right? Yeah. Okay, and now can I plug in that function here? Okay, digit is a function taking a string, returning a pair. And if this is good, okay. All right, we're on our way. Let's see. So what I want to do, let's see. So how's the test look? Let a parser equal parse with this digit parser. The value is parser.parse. So we're calling our parser to get the function, which is digit, past the string 0. And we're saying we don't think it's going to be nil, and we assert that its value is actually the value. Okay. Now, I think we've done the first thing, but I want to refine the way digit works. And I'm going to change this to match. I think that's going to be a more generic, better name. Okay. And match takes a string and it's going to say, let me undo that. Let's say match. So what I'm doing here is I'm generalizing, basically. So I'm going to say match. I want to extract out this 0. Well, 0 is character 0. Can I convert it to an int? No. Oh, I gotta say return here. Single quote literal found. Okay. Let's. I can convert it to a string first. How ugly. Characters has property whole number value. Convert to int. Okay. didn't see anything. I guess characters are that. Is that gonna work? String, no. Fiddling around these types. It's going to be a theme here. Character equals 5. Okay. And does it pass? So I'm not changing anything at this point. I'm just refining how I do this, which is some people call it prefactoring or nesting or making a room. But I'm trying to get it so that this thing is more parameterized and usable out of this. So let's do this. Okay. And we don't need that anymore. All right. Succeeded. Command code side failed. Yeah, okay. I'll deal with that another time. Okay. So my test succeeded. Let's push this. Whoops. So initial. All right, let's make sure everything else is doing better than this. So here's cat light. It brings up a little dialogue and it tells you I made the test fail 2 times and I ran them green 2 days ago. And in the next 5 minutes, this thing will Jenkins will kick off somewhere else and basically build what we have. And then Catlight will pick it up and, well, potentially change the light color, but hopefully just add another little green square over there. Okay. All right. So here we are. What I'm trying to get to, what I would like to get, and maybe I should do, I don't know, I should maybe do a little triangulation kind of thing. But what I want to do is I want to have a function match that takes a closure and decides if the current character meets the criteria of the closure. And if it does, then we're okay. Okay. Do I need I don't know if I need that for that. Let's define that thing. All right, so if I had this thing, these extracts didn't seem to be working, it would take a string. Is it a parser too? Maybe it is. Okay. What I would like to do is I would like to call that thing. So let yeah, we're getting deeper in. I don't know if it's too deep. We want to get the value rest is match I'm not feeling good here. All right, let's do this. Okay. So I should be able to parse, and I don't know. I don't always make a new test. Sometimes I do this and just modify a test, and this test will fail because this only works for character 0. Someday it'll fail. Okay, 1 not equal 0. Okay, so I could have duplicated the test. That's fine too. Just the way I'm doing it. All right, so I'm saying this character is really string dot first, which is optional. So I'm saying there really is one. I'm hard coding that assumption, and now instead of just taking a 0, hard-coded 0, I'm actually looking at the string you give me. So I'm driving behavior forward for sure. Okay. And my tests are passing, or my test is passing. All right, so I've made a move forward at last. All right, and I don't know how much I want to get, how buried I want to get, but I'm already feeling a little nervous. Well, the next test. Okay, let's. I'll say triangulate to parse 1. I don't know, you could spend a fair bit of time on this very first test because there's definite infrastructure you want to get going for these parsers and all that stuff, and we can use a lot of it. Let's see. So 4020. I would like, well, I'm already like I would like to parse 42, but right now I would get back 4 and that's it. Okay? So we'll just change this just to prove a point. I expect it to fail with assert equal 4 instead of 1 because it's going to get the first digit, but it doesn't pull the rest of the digits, and that's not good. Okay. The other thing going on is I'm doing this char whole number value thing. That's not parsing. That's interpreting at some level. And really, for us to basically, if we're going to get this AST out and not just a Boolean that says your parse was successful, the AST has to hold values. And one of the values it's going to hold is this number that comes out. The number, we're going to have to keep track of the type of it and say it's a number and its type is Elm number. We're going to be reusing words a lot. So I guess I have to learn to say Elm such and such. Okay, but this is where we were. Parse 1 works. Okay. Now, we haven't dealt with the error case. What if you come in and you give me an empty string and I call first on it? Well, ooh, that's bad. Don't do that. Okay. What if I give you something that's a letter? Ooh, that's string.first is okay, but chart a whole number value. Who knows what that'll do? Did we still have that up there? No, we didn't explain it. I don't know what it means. You know, it could interpret it as hexadecimal and give us the value for A, or even base 36 if we put in Z. You know, I just don't know what char whole number value does. I assume it's parsing it as a decimal, but yeah, okay. And then I still have this string mess that I'm parsing strings and I don't really want to. Now, what's making me say that? You know, it's not like we've run a performance test and found the issue, but there's an issue there. Okay. Now this digit is only supposed to match actual values. I guess whole number value will come out bad if it doesn't. So we can let's try this. Parse doesn't match non-digit. Parse digit. Parse digit. Okay. And this function, well, this is going to be similar. Okay. This is going to be assert nil. Value. Okay, so the value comes back as a question mark, meaning it could be nil. And we're saying if it fails to parse according to this parser, it should return nil. Okay, and if we parse A, all right. Parse digit, parse A. I'll take this off and assert nil. Okay, this test should fail. I don't know if it'll blow up in here at the exclamation point, probably. Yeah. Okay, found nil while unwrapping an optional value. Okay, we can stop. All right, so now I want to do basically if let result equal this. If the result is a whole number value, then we're going to return it. We're going to return this. Okay. I guess we'll return that. Okay. And otherwise, we are going to return nil. Okay, so if we do parse this character and it comes up as a digit, we're going to return it as a number. And if it doesn't parse as a digit, it comes back nil, and we say the parse failed. Okay, so we get our Boolean. So we still have that Boolean embedded in there. It's just nil versus not nil. I don't know, maybe better ways to do this. Yowza. Okay, so char whole number value. Let's go read the documentation. Apple. Okay, it's an int, does not represent. Oh my, it accepts a lot of stuff, doesn't it? There. I don't know if it's. Does it take Roman numerals? It gives me something for A. A goes to nil. Is my logic backwards? Okay. Where's my logic? If it is a whole number value, return it. Otherwise, nil. Assert nil. Oh, it passed. Okay. Did we ever see it fail? We did. We saw it crash. Okay. Okay. Yeah. Pushing on an open door here. All right. So we parse digit of A fails parse. I can even say returns nil, I guess. Okay. Now we've dealt with the first return value this side, but here I'm returning junk. We've got to do some assessment on that. Well, I think I can make the case if I return parse1x as a digit, one character, this test should now fail. Oh no, it won't fail. I'm not looking at that value, but I should be able to say assert equal. I should have just the string x for value.1. And I can make this nicer. I can say, well, I'll start calling it AST and rest, and then I can assert on those. Now my tree is not very tree-like, is it? Well, let's try this again. Okay. So I parse the one, and my stream that I get back should be the rest of the input. Okay. And now this test will fail. Okay, not equal to that, and that's because this should really be the rest of the string. Rest. Let's see. Can I navigate up? Yeah, strings. First. Drop first. Okay. Why is that ambiguous? Can I convert end string to substring? Oh, okay. You can see I'm already getting buried in type switching and stuff like that. All right, so string.drop first gives you a substring, not a string, and it makes for very efficient. Well, if I didn't turn it back into a string, it would be efficient if I were comfortable working with the substring. Then the substring can just point into an existing string. It's got a little overhead to create the pointers to it, but it doesn't have to have the body of the string there. All right, but here I'm doing it this way. All right, but I do think my test will pass, even though I'm not happy with taking a subsequence, wrapping it back up into a string and all that stuff. Not good. All right, so that covers the case here. All right, so we got two of the three cases I care about covered. Well, yeah. So if it matches, we get it, and we get the rest of the string back, which is what we expect and want. That's the behavior we want out of this stuff. This one, if we attempt to parse a digit with something that is not a digit, then we expect to get a nil back, meaning there was a syntax error in this. We do not match. All right, now I got one more case. Let's see. The third case I'm thinking about is if there's no string there at all. All right, so let's test parse digit. I don't know what we want to say happens. I really want to say doesn't match end of string. Okay, and now we're going to look at just an empty string. because it'll blow up. All right, so if we just parse nothing, and we expect a nil. Okay, so I expect pass crash. All right, unexpectedly found nil while unwrapping an optional. So this first exclamation point says, oh, I can just always grab the first character, no problem. And that doesn't really work. Okay, now there's different ways to handle it. Well, I don't want to say the simplest. One way would be I would protect this and say if the string is empty, return nil. And I don't know, that's not so terrible. The other way is I put a sentinel in and I take my original string and I append some character that should not happen. I don't know if there's an ASCII into file. I can certainly use null, which is ASCII 0, make it a C style string, I guess, and treat that into file. I can look at it, which it's nice that way. It says I can look at it, but I can't. But I don't want to continue past it. So I have to be a little careful not to let things just chew up arbitrary characters because null's a character. But maybe I was originally assuming I would do it that way. It's definitely what I've done in commercial compilers and stuff. But you can put the sentinel in and decide if it's really the end of the string and whether you should blow up or just warn about it or something, because people theoretically could put that character in. But I'm going to say instead, if string dot is empty, return nil. Okay. And now string.first is always legitimate because if you get this far, you are not empty. All right, should pass. Great. Okay. So the commitment I'm making with this is you better not go past the end of your string. If you try, you better not match. And I don't know, I may end up with duplication on this in who knows how many places. And maybe the sentinel would be better. Because if I had the sentinel, then I drop line 17 and string.first is null, 0. And that's never going to be a whole number value. So it would come back and return nil, and that'd be fine. I think if we refine, we'll refine the way we match characters, and we'll see. We'll come back to it at some point, but doesn't match end of string. Okay, so that's good. I mean, I'm protecting myself on these 3 situations, and I could drive off and I could have gone for the test with 42 next. It's very tempting. Get the happy path stuff, but I don't want to go too far without dealing with syntax errors and things like that, because if you skip dealing with them, then what happens is you're going to write a test case at some point that has a syntax error and things are going to blow up and you're going to be like, why is this blowing up? I don't want to be there. And if the better my syntax checking is, the less I have to worry about it. The other thing is my look at parser combinators, I don't see quite how they handle syntax errors. I see them detect them, but I don't see them give you a nice error message like Elm does. This should have been an integer, but you put a character in here that doesn't make sense, and what's going on? What I see is like, oh, I see an X. Stop. You failed here. Okay. Now Run it again, fix one character, run it again, and you can see if you failed at the next one. So there's a reason commercial compilers don't very often have a mode that's like fail at the first problem. It's not super handy. Now, if you're in a mode where like you can never make mistakes, or if you did, you could fix it with one character, it might be okay. And there may be things like that. All right. But let's see. So here we are. I don't know. Can we go to interpret? I don't want to go too far down this thing with ints as my AST either. Okay. But I don't want to go down too far without interpreting either. So, okay. Let's do this the similar way. Let's get this one. Well, okay. Parser is parser.digit, AST rest, and we'll just go back to 0. And we're not going to assert on AST. That's somewhere else. Okay, but we're going to call our interpreter, and we want this off the AST. Okay, parse the digit, get an AST, pass it to the interpreter. The interpreter is going to give us back some sort of output. And I'm going to put that I'm going to see the test fail. Oh, well, that's not a good reason to fail. Let's make a class up here. And I don't know if it should be a struct or class. Okay, class interpreter. It's got an init. This thing we're saying is an AST. Init takes an AST value of AST. Well, we're interpreting it. Let's do it like this. Let's create it first, and then let's give it an interpret that does the thing. And this thing produces, well, I'm saying it doesn't produce anything. Interpreter. I guess I'm saying he has a variable output of type string. Constant interpreter cannot be constructed, has no initializers. Okay. Value of tuple. Oh. Interpreter. Okay, we're going to have to. AST could not be inferred. Well, let's see if we can hard code it. The mutable value was never used. I guess we don't care about that. Okay, now let's get a failing test for the right reason. All right, 0 number is not equal to blank. Okay, we initialize it to blank. All right, so it's time for another break. So let's take 2 minutes, grab a drink, whatever, and we'll come back and make this thing work. All right, see you in a bit. All right, welcome back. Let's see. So, in the meantime, I just created this little to-do file, and I'm sorry. I'm sure it's a critical call about my car insurance. Okay, let's see. So I'm creating this to-do file and just kind of putting in what we're doing. So we're parse and interpret simple integer. Okay, and I don't know. We call that a story. It's a little basic. All right, now, yeah, usually I get that to appear as a chiron on the bottom of your screen, but I'll have to work on that. Okay, so we got the tests. Number not equal, zero number is not equal to empty string. Okay, now this is definitely placeholder code. I'm just trying to get the shape and explore the shape of having an interpreter involved. All right, so and I don't know. Do I like it this way? Well, we can certainly make it pass pretty simply. Okay. Do I want... I think what I want to do is type alias AST equals int for now. Okay. And not be generic. Oh, no, it can be generic. I think I can. I think that'll build. Okay. All right. And so interpret, it's giving me a value that's an integer. This is our initial cut here. And the integer, we don't know what value that is, but what we're going to do is we're going to say output append. All right. And let's take the value is a number. Okay. And see if that'll work. Be right there. All right. This gives us a chance. Do I like having interpreter.interpret? Should interpret produce? What should interpret produce? Now, we'll have to see what we want. I don't know. Okay. And I want to start generalizing already, and I don't know if that's a bad impulse or not. But what I can see is this int is so inadequate. What I would like to do is I'd like to define an enum. I think we call it that here, right? Case. Okay, so let's invent a type, and we're going to move everybody to use that. Okay, so the enum type, I'm going to call it AST2. I'm going to call it AST. That's what I'm going to do. All right, and my case is Elm. I don't know if I want to say Elm all day, but Elm integer. And then it has a value of type int. Okay, so Swift has enums, and it has enums that take parameters. And we're going to give it the parameter that corresponds to the integer value. So instead of AST equals int, it's going to be AST. I don't need these anymore, which we'll see if that's a good choice. AST. Okay, so element, and I think we can let the cases guide us here. Interpreter of int. Okay, we don't specialize it now. Cannot convert value of int to AST. Let's make an Elm integer of AST. I don't know if I have to qualify that. Okay, so what I'm doing is defining this intermediate format. It's not a tree yet, it's just a leaf, but it's legit. Okay, so this is moving it back. This is okay. But I don't want to do it here. I want to do it in my parser. Okay. Yeah, we got to make our parser deal with it. Okay. Let's do a switch on value. And let's say case Elm integer. Let number equal value. I think that's the syntax. And close my case. Expected separator. Oh, I think I just say let value. Or let number. I don't know if I'm reusing too many words. We're going to have a lot of these around. Okay, so interpret takes an AST. The only possibility now is Elm integer with a number, and we append that number, number. All right, and our tests should pass. All of them. Yeah. Okay, so there we have it. An interpreter that handles one-digit integers. All right, let's move it back. AST Elm integer. I want the parse to produce that. I want my digit parser to produce that. And this is where I'm getting mixed up on my types. Int string digit. This I want to be AST. String int char whole number value. Okay. I don't want result. I want Elm or AST dot Elm integer of result. Okay. Cannot convert value of that. Do I need to compare these for equality? I don't know if I get them for free. Now this is already an Elm integer, so let's delete that. Okay. Global function equal must conform to equatable. All right, so let's take AST dot remember how you compare these enums. Let cannot be. Oh, golly. If you're there and know there's the quick way to do this, let me know. Let's see. Swift get value out of enum. I don't want to do the iterator number. Maybe I got to switch on it. Associated values, that's what I'm after. Yeah, that's just using a switch. Okay, so we'll do the switch thing. Okay, so we're pulling out that value, we're checking it, and checking the rest. All right, let's run. Should pass. Okay. All right, so we've got the interpreter that's working on an actual AST. He's good. All right. And we've got this digit class. All right, I'm still kind of I'm wishing I had Well, I'm wishing I had characters instead of strings. Let's see what Character view. Maybe they weren't lying. This might be the better place to start. String.character view is a view. Yeah, so this is talking about what I was saying with multiple Unicode code points. Like all these, we've exceeded the 16-bit Unicode that they had at one point, right? And you can have 4-byte characters and probably more for fancy things, emojis and all that stuff. And you get them, they're multiple character things. But one of the challenges is some of them are composed. You have multiple ways you can compose them. So I don't know. It seems like there's one combining character maybe lets you backspace. So if you do A backspace B, it looks like an A with a B on top, which also looks like a B with an A on top. So doing it in the other order might be acceptable and yield the same character, even though it's 3 different bytes or 3 different, whatever they are, partial, parts of a Unicode character, I guess. Okay. I don't think we're going to do that right now. All right. What else can we do? I mean, at some point we have to pull these things out into a separate class just to be interesting. And maybe that's as far as we will go. The next step is, from our parsing point of view, is really multi-byte characters. Or maybe it's the type. This thing is, that's probably a good one. Right away, right away, we have to deal with this number type. Let's find the documentation on that. Elm number. Elm data types. Are you going to tell me? Floats and ints both exist. I don't know what they call it in Elm, though. So what I can't tell is when I create this literal 7, why does it call it a number and not an int? Okay. So I think that's a, well, who am I to judge? But it's already a complication like right away in Elm that I have to master. I really kind of, I don't know. I would be just as happy with a solution that was like, it's an int. If you want to convert it to a float, you call it toFloat or something. And, you stay ints operate on ints and floats operate on floats. And if you want to mix them, you do some conversions. I don't know. Maybe it's just what I'm used to, but it feels like a cleaner separation. So instead, now I have this thing of 7 is possibly an int and possibly a float, and we don't know which. And so let's call it a number. But if I call that 7 backslash or double slash 2, that's an integer operator that returns a true int. And so we know we get an int, and 3 of int halfway down here, it comes back from that operator. So the question is the type of this thing, like, what are types? And I don't know how to interpret it really. So I could interpret it as this thing, parsing this int gives me a set of possible types, int, float. And something knows, hey, if you see int, float as possible types, it's really a number. Okay. Or it may be that parsing 7 gives me a number. And somehow, when we go to match number to other types, it's happy to say, like, Oh, number. Okay, that I would accept an int or a float for that. So I don't know whether to call this thing number, and then when somebody calls a function like 7//2, they have to figure it out. And they do it also. Yeah, are they going to show me this one? String is a sequence, characters a fraction. No. Elm has 3 or 4 types. Well, maybe several. It has number equals int or float. It also has sort of a string one that can be a string could be an array like object or something. I don't remember what they call that. But I want to represent my number type. Is my type ambiguous, int or float, and you got to interpret it, or is my type number and you just gotta pass it along, and numbers just treated special, and something knows when it's matching a number that it will accept an int. Okay. That's probably the simpler start, but I feel like it really is probably a union. So what other situations can I get where my type is not a unitary thing, it's a union of other types? And do I have full generality on that? And I think I don't in Elm, but I'm learning. Okay. And part of my process for this is I'm not going to be coding. I'm not going to code things in advance. We're just doing let's code style. You take what you get, as you can tell. But I will study between things and try and figure these things out. But I think what I'm going to say is this type is number, and we're introducing an Elm type as well, and I think that's part of the AST. Um, it's not just enough to know the number. I think we should know the type. Okay, and um, types are another thing, I guess. The type structure we're just gonna have to figure out. I mean, for now, I will just put number, but it it seems it seems like it's going to get more complicated. I mean, we got record types coming. You can have fields A of int and B of string is not the same as a record with A of string and B of int. All right, let's see. This does look wrong to me in the sense of normally we lowercase these. So let's refactor this. Elm integer with lowercase e. All right, and I will run the tests. Ooh, I don't know if I'm running the UI tests too now. I can make a test scheme that only runs the ones we care about. These tests pass. All right, let's commit. What's our difference here? We switched to an AST type, I guess. All right, and I think, yeah, Catlight here is green from our earlier build. All right. Right. Okay. So I'm gonna generalize this thing. I'm generalizing it with a constant, so I don't feel too bad about doing that. Let's make types. Are they Elm types? I may get so sick of that prefix. All right, and one type right now is number type. Maybe just number. We'll see if that works. Okay, that's what that is. All right, but now I'm saying this thing should not just be an integer. It should be the type of it as well. Is type okay? Okay. Now this should blow up in places. Yeah, there we go. All right. So here, this should now be elm types dot number. And we don't have to care. Oh, we kind of want to. Let type. Okay. And now it's going to complain that I'm using it. That's fine. Let number. Let type. Cannot convert int to expected. Okay. All right. Let's see these things come through. So, Elm integer type. Well, the type should be elm.number. Okay, so let's assert equal elm types dot number should be type. Okay, so this test should be good. Seeing as it's the only type that's allowed or possible. Yes, okay, and then here's this one. Now this, I want number to come from this. So let's extract this out. Well, okay, I want to make a function, private function, format type of type value of elm types. That thing returns a string. Okay. Right now it's going to return number. Just doing a small step kind of thing here. I'm going to get format type of type. Okay. Value type now is used. This should pass. And then I'm going to put the formatting here. I could have put a string on my elm type. But it's not inherently part of the type per se, and there might be reasons I want to format it differently or something. But let's define let's define a type string equals is of type. I think I can just say equals. I'm going to make a hash type. Elm types dot number goes to number. Okay, and let's take type string sub value. Return that. Cannot call value of non-function type. Type strings. Do I do it this way? I don't remember. Sub value. I'm saying it's always going to be found because elm types is going to be a type that I do. If I don't find it, there's an issue. May change at some point. All right. It's definitely getting more complicated. So I think it's handy to have it in here when we're just starting, but I'm going to pull it out into separate classes now. All right, so let's make a parser that contains these things. Parser, that's actually pretty accurate. Struct parser, that. I think we have work to do there, but that's okay. We need to make an AST. I think we'll pull both these together. Okay, and then a type interpreter. All right, I will build. While that builds, okay, we'll run these tests. Let's just get back open. Let's hope this all builds. All right, so I'm kind of taking a to-dos. I will work on that to-do file, show it, at least the headline, and we will I'll work on that permissions issue. Okay, and I think our next place to pick up is the 42. So we'll add a test for parsing 42, and I think this will not be Whelm tests. It'll be more like number tests or something like that. And let's see, 42. So we'll have to work out some sort of parser that takes many digits. Okay, and with that, we'll check this in. Split out production versus test classes, and I'm going to try and indicate refactor. Okay, and then this cat light is probably our older. I mean, it's not the one we just checked in, but we've done enough that the red ones fell off the back. All right. So with that, I believe we will call it a wrap for today. We'll pick up next time. Hopefully I'll have the background work done, and we just have to define a parser that handles multi-digit integers. With that, I don't think our interpreter will change any. I think our interpreter is already locked in and doing the right thing for what it does. We'll add some other types and get going there. I don't know. At some point, not too long down, we should add an operator and see how that goes. And our ASTs will really be trees at that point. All right. Well, thank you for joining me. I hope you can join me again. Next time is tomorrow morning, Wednesday, 9 to 11:30 a.m. And after that, it's Thursday, 1 to 3 p.m., all Eastern time. Tuesday, Thursday at the same time. So like today. And thanks for joining me. Take care. I'll see you in the future. Bye-bye.